I finished my master's degree this past May in space resources from the Colorado School of Mines. I focus on a variety of different subjects, whether it's asteroid mining, lunar surface excavation projects, and Mars uh, surface operations as well. So, most interested in Sabatier reactor development on Mars, but looking into the future, what's more important is like mega scale processes for this. So like large scale engineering of a whole entire planet, which is called planetary engineering. And I'm just going to go over a little pitch deck, slide deck to teach everyone about what is terraforming, what is planetary engineering. This is all just from personal research that I've done, also affiliated through the Colorado School of Mines. So I'll share my screen now. All right, so we're going to go over the case for terraforming technologies. This is a painting on the right that I did. I painted a sphere of Mars, how it might have looked 4 billion years ago. So what is planetary engineering? The definition of planetary engineering is the development and application of novel technologies for the purpose of influencing the environment of another planet. Could also apply to the Earth. So the human ability to engineer advanced technologies that can change the planetary environment when applied at a large scale. So why do we care about this? I did some previous research back in 2018 using a smartphone iPhone application called Terragenesis. And I exported the data and tracked what we expect to see from potentially changing the course of a planet by altering its atmosphere and thus altering its surface. If you're interested, this research is available on ResearchGate. And I also summarized that longer paper into a shorter paper, and that's this one, Planetary Engineering Theory, and its application to future terraforming for colonization. This one basically breaks down the simple theory. The mathematics has not been numerically unpacked, but also highly recommend if you're interested to go check this one out on ResearchGate as well. But why does this matter a lot for Earth? From the IPCC 2021 report, it's pretty obvious now to most people that we are altering the surface and atmosphere of our planet drastically. We even have the new geologic period here, the Anthropocene, that we've been changing. This is proof that we can engineer planets' atmospheres. Right now we're doing it inadvertently, but it's really important to notice that this is mostly all driven by CO2 concentrations in the atmosphere. So what's the number way to reverse this? Well, that's taking CO2 out of the atmosphere. So the problem is that CO2 is causing irreversible damage to the planet's ecosystem and the oceans. And if not properly dealt with in the near term, we could see some big issues. Basically, the group that I've fallen under would be that if we use technology to get us into this mess, that we should be able to use advanced technology to reverse this mess. I don't see anytime soon humans stopping CO2 emissions, so it's better that we use technology to start to reverse it. So then people might ask, what about electric vehicles and solar? I completely agree. Electric vehicles and solar should be used, and we should increase production of these, but it's not sustainable to be able to fully affect the total climate output. So we need planetary engineering technologies in order to solve this problem. So renewable power terraforming technologies could be intelligently designed and implemented at mega scale to reverse the effects of climate change by capturing CO2 from the atmosphere, whether physically capturing it and then using things like solar powered Sabatier process to generate fuel that's usable, or potentially geochemically capturing CO2 and turning it into carbonates that can be used for cement production. So how will we do this? Well, this is a fundamental and then concept tree about what I'm thinking about. This captures everything from start to finish. So in general, when you're creating anything, you need to start with raw materials. So mining, those materials need to be processed. Then once they're processed, then the beginning of the manufacturing process can begin. Ideally, we would use renewable energy. So that's a combination of solar, wind, nuclear, hydroelectric, and geothermal that would then power our CO2 removal system. The CO2 removal system could there be, like I said before, geochemical or purely physical, like via engineering. And ultimately, we are getting usable end products from this CO2 extraction system, whether it's a calcium carbonate for use in concrete, whether it's biogeochemical products, if it's a biochemical reaction, and then rocket propellants is one thing that many companies are interested in, and anthropogenic hydrocarbons as well. Basically, so we can start making fuel from the atmosphere instead of taking it out of the ground. And what's really important as well to recognize is adding the space economy to this flowchart really opens up a lot more of the economy. So space resources enables more materials that aren't readily available on the surface of Earth for producing solar panels, batteries, and it's really important to keep in mind that the space industry will enable these kind of technologies. So what is the chemistry? I wrote a paper on the resource utilization on Mars. If you're interested, that's where this graph is from. But we're interested in, this shows the chemistry for producing usable end products like rocket propellant, water, and plastics from an initial chemistry of just water and CO2. What's the catch though? Different types of CO2 removal is definitely difficult. It requires substantial R&D. It's difficult to scale it up. It requires significant power demand and labor. Large-scale production and installation is also daunting. So there are a handful of companies interested in these kinds of technologies. There's a new startup that's founded in Burbank, California called Terraform Industries with Casey Hammer. Casey Hammer is basically working on this problem. If you're interested, highly recommend to look them up. But it is definitely very difficult, and we need more people involved in this. There's also potential for source capture at the top of power plants, at the top of a smokestack. But ultimately, here's what we want, right? It's the same thing before. So the CO2 removal system could be made up of multiple different subsystems. So atmospheric separation, just physical, or geochemical weathering. And then there's the biogeochemical solutions, which I'm not as well versed in, but I know a lot of people have often said that biogeochemistry is a good way to do this. And then source capture, that's also important. So, because then you don't have dilution. If you're just trying to take the CO2 out of the atmosphere, it's about like 410 parts per million. So it's more difficult than just to capture it at the source of a power plant. And yeah, that's the top level tree for just the removal system. And yeah, that's let's see, that's pretty much it. Why does this matter for Mars? Well, it's planetary engineering, essentially terraforming. So what we care about for the Earth, for saving the Earth, reversing climate change is equally important for enabling humans to explore other planets. Yeah, thank you. I'm free for questions. Let's see, I'm going to look in the chat. Yeah, see, Cole posted the link. That's good, and doing a pretty horrible job at it on Earth. Yep, it would be correct for sure. So, kind of the point of this, want to get a general buy-in from everybody, whether or not like you're interested in this stuff or not. I was hoping that this would be very educational, um, and that everyone should be thinking a lot more about these kind of things. A lot of times, yeah, CO2 seeding for albedo change, yeah, for sure. Yeah, geoengineering also very applicable. I don't think that adding things to the atmosphere is necessarily the right answer, um, but I feel like taking, yeah, the crux for doing this, yeah, for sure. Biological approaches would definitely need a lot more help with the biological approaches on it. The difficult thing, one of the most important things actually about this technology is that in the future, taking CO2 out of the atmosphere will become, and to making fuel out of it will become more affordable at the time when solar panel technology becomes cheap enough. There's a part where the curves cross, and you then become net positive in producing fuel, but the cost of solar is not quite there yet. So in the time of this this decade, exactly, yeah. Anytime combustion takes place, that's right. So that's why we should, as a planet, just stop as or like reduce all types of combustion as much as possible. Um, and then, how do you take heavy equipment to Mars? To answer that question, yeah, it will be a Starship super heavy booster. Take it from the planet, and then Starship can bring like 100 metric tons to Mars. Um, where can we learn more about terraforming? I would recommend do some research on ResearchGate. I have a lot of information on there. There's good information on Google about it as well. When do you think we have it? How about planet while terraforming is done? Let's see. Mm, well, for the case of the Earth, like in 100 to 1,000 year time scale, we can stabilize our climate back to the way it was like 100 years ago.
I
The
meant
impact on
for
human health before and after terraforming should be a positive impact after terraforming. Basically, what human health skill is needed to do terraforming? Awesome. Yeah. So if you're in the health industry, there's a lot of human skills that are needed for this. We can do things like prove that atmospheric contents are bad for humans, bad for the human body, and that these kind of things, whether like taking CO2 out of the atmosphere is not only one of the goals, right? We could take pollution out of the atmosphere as a whole, right? But you're saying so for Mars, I mean, we need doctors on Mars, so all the human health skills are needed to do terraforming. Everything involving humans, human health, it's all 100% applicable in space. We're going to need a lot of doctors. So, and any consideration to an artificial Mars magnetic shield? Yeah, I know it's a Cole's company. They're Magnetospace. They're interested in this. I for one think that we don't really need a strong magnetic field on Mars until like maybe 1 to 2,000 years from now, and it also might not be 100% needed. The reason why it's needed is to prevent the solar wind from stripping as much of Mars's atmosphere. Since Mars' atmosphere is mostly gone already, it doesn't get, there's not that much to strip, um, but yeah, it's when we start adding atmosphere to Mars in the future, we will need a large magnetic field. But in the near term, a magnetic field and small magnetic fields are not necessarily required.